Okay, Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha online college live lesson, A-level maths year 2, pure maths, going through the Edexcel Pearson year 2 syllabus for A-level maths, and it's chapter 2 and continuing functions. Okay, just before we go into our topic too much, I want you to just do a little warm-up exercise. So the warm-up exercise is just think of three numbers between 1 and 20. Any three numbers between 1 and 20. Make it easy for yourself, just do whole numbers. Okay, and now that you've thought of three numbers, I'm just going to do the three spaces for the three numbers. Then for the numbers that you thought of, whichever numbers were less than 5, I want you to add 1 to that number. And whichever numbers were more than 5, 5 or more, then I want you to double those numbers, times those numbers by 2. And then when you add up your numbers, that's your final score. And if you just type into the chat window what your final score is, for example, maybe I thought of the numbers 1, 4, and 10. Then the 1 and the 4, because they're less than 5, I would add 1 to them. And the 10, it would go into that second category, so I times it by 2. I would double it. So my final score would be the 2 plus the 5 plus the 20 to make 27. If you can just work out what your score is. Okay, excellent. Inshallah, well done. So that's an idea, or that's an example of what we're going to do today, where we've got a split function. Split meaning that depending upon what numbers go in, we're going to do something different. In the first box, we were adding 1 to the numbers going in, and in the second one, we were timesing the numbers by 2, and it depended upon what was going in. So the proper name is called a piecewise function, and it's example 9 in the book if you're following the book. So we have a function, but depending upon what number goes in, we're going to end up doing something different to it. So for numbers that are less than or equal to 1 that go into the function, we're going to do 5 take away 2 times that number, x. And for numbers that are bigger than 1, and I think I've got the equal on the wrong one, so x is less than 1, we're going to do 5 take away 2x. And for numbers that are bigger than or equal to 1, we're going to do a different function. And the function here is going to be x squared plus 3. So just like the example we did at the beginning, we're going to look at the number we're putting in first to decide then what function we're going to use. In the beginning, we were adding 1 to some numbers, we were doubling others. So here we're going to be using one function for some numbers and doing x squared would be easier, x squared plus 3 for others. And the question is to sketch the graph of this function, this split function. So let's get some graph paper and show you how that's done. We take it one function at a time. So this function here, 5 take away 2x, don't worry about the less than 1 for now. Just think the y-intercept is 5 and the gradient's minus 2. So it's going down. So that means it's going to be going from 5 with the gradient of 2, something like that. And if you extend it both ways, and now look carefully at the limit we want to put on it. It's less than 1. So that means less than 1 is where this function is going to work up to about here. And then we don't want that function working anymore. So we can rub out that line. And because it's strictly less than 1, that means we don't want to include 1. So we're just going to use a hollow circle to show that that function ends there. Now let's take a look at the x squared plus 3. X squared is a U-shaped graph, and the plus 3 you'll find out later is going to shift it up by 3. You probably did that at GCSE anyway. So to draw that, you'd probably just do a little table. So if x is 0, then 0 squared plus 3 makes 3. So I know I've got one of the points would be here. If x is 2, 2 squared, just ignore the limits for now. If x is 2, then 2 squared plus 3 would be 7. And you can continue like that until you've got an idea of how that graph is going to look. So then you can join that. I'm just using my mouse and finger here, so it's not going to be the neatest U shape in the world, but just bear with me. Okay, so something like that, but a much smoother U shape, which I'll try and redo. And now the important thing is we're going to rub out some of it anyway, because this function is for the numbers we're putting in, which is bigger than or equal to 1. So it's just going to be from this side onwards. So we don't need any of that on the left. That's where it's going to start. So we just want to draw a nice little circle there. But this time we're going to fill that circle in because it is going to include 1. So it'll just be a bit lower than that. Let me redo that. So it'll just be here. And this time fill it in. So the hollow circle doesn't include it. The solid circle does. The way to remember that is remember more ink, more meaning. So if you've got more ink, which is filling in the circle, then that means more numbers. So you're including the 1. Okay, great. So that's the sketch. Yours will hopefully be more smoother if you're doing on pen and paper. And then the second part is, well, solve it. Let's suppose the equation was, we want f of x to equal 19. What would the solutions be? So 19 means that y would be equal to 19. When it says f of x equals 19, the function of x has to give an answer of 19. So y is where the numbers are coming out. So 19. 19 on this graph you can't really see, but if you could see it, then what you'd see is a line going across, and it would hit the blue line around somewhere on the left, and it would hit the green line somewhere on the right. And we want to find out what those points are. We can't read it off the graph because the graph doesn't go up to 19. But what we know is that I need to put 19 against the blue line function. So the blue line function is the 5 take away 2x. And then I'll need to repeat it for the green line function, the x squared plus 3. So let's do it one at a time. Let's use blue. Let's take 5 take away 2x equals 19. Let's solve that. So we have 5 equals 19 plus 2x. Take the 19 across, minus 14 equals 2x. Divide by 2, so that's minus 7 equals 2x. Sorry, minus 7 equals x. So we know That's one solution where x is equal to minus 7. Try the second one yourself. Can you think what the first line would be? I need to try and find this point here. Y is 19, so I've imagined that I've gone up and drawn a line going straight across at 19. If you can think of what the equation would be to begin with, type it into the chat box. Pretty much the same as the first one, but you're starting with the second function. Okay, nothing yet. So this one would be good. X squared plus 3 equals, we need to finish it off. X squared plus 3 equals what? Okay, good. X squared plus 3 equals 19 is perfect, mashallah. So we'll just take that function and we'll put equals 19. Again, then we want to solve that. Take off 3 on both sides and you can carry on the rest to see if you can get the answer before me. So taking off the 3, I'd have x squared equals 16. Be careful here because when you have x squared equals something equals 16, the x can be either the positive or the negative, because when you square a positive or square a negative, you end up with the same answer. So you want to put both answers initially. X is equal to, hopefully you got it, plus or minus 4, good. And then out of those, you want to just choose the right one. Remember, we're looking at the green section of the graph. The green section of the graph only works for numbers bigger than 1 or equal to 1, so it can't work for the minus. So it's just the plus 4 we need. Okay, and that's how you solve a split function. Join me again for another lesson tomorrow. Assalamu alaikum wa rahmatullahi wa barakatuh.